Hello everyone, my name is Ike, as in I-K-E, and today we'll be looking at sets and operation of sets. It's going to be a whole video tutorial series on sets, the topic sets. But today we'll be looking at definition of a set and set notations. But before that, let's understand what set is. Set theory plays a very important role in the study of mathematics. Many branches in mathematics can be studied more easily and precisely with the help of set theory. You have already learned about sets and some basic operations involving them in your junior high and maybe your primary education. But it's also important that we revise some of these concepts so that we can be on the same page, because we'll be using the language of sets throughout our study of mathematics. And so let's dive in now. Definition of a set. Now, how would you define a set? What is a set? In everyday life, we often talk about the collection of objects. For example, a team of players, a group of students, a collection of flowers, a box of chocolate. We use the word set for a special type of collections. Set. We use it for a special type of collections. And usually when you have a set, they have something in common. They have common characteristics, a common feature that runs through all the members of the set. Now let's take, for example, this. Let's take, for example, the days of the week. So we have Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, and Saturday. Now that is one set. This is one collection. That is one collection. So let's write them down. Sunday, I will shorten it because of space. Monday, we have Tuesday, we have Wednesday, we have Thursday, we have Friday, Saturday. So if you look at this collection, they are 7 in number. If I should ask you, what do they have in common? What will you say? What do they have in common? Well, you will tell me they are the days of the week, and that will be correct. Now, let's look at another example. Example 2. This is example 1. So example 2, we have happy people in your class. Happy people in your class. Okay, that's another collection. Now, the first example is the collection of days of a week, which you are correct if you guessed it right. Now, in the second example, the term happy people is relative. When we say something is relative, it depends on certain factors. Okay, So let's take, for example, Ajua may be happy by Ya's opinion. So Stephen may say, okay, today Chris is happy, but Gertrude may think Chris is not happy. So one person may think this person is happy, another person may think the same person is not happy. So it's relative. So we cannot decide whether to include Chris in our collection. But in the first example, we can definitely decide whether a given object belongs to a given collection or not. Because when you look at the first example, this example 1, we know that they all belong to the days of the week. They are all days of the week. So it's a definite collection. So what we are trying to say now is that in defining a set has to be a well-defined collection of objects of the same kind. Let's write that down. Just a moment. Okay, move it up. Almost there. Okay. Okay. So what is a set? A set is a well-defined collection of objects of the same kind. Good. So that's the definition of a set. Okay, so this is the definition of a set. A set is a well-defined collection of objects of the same kind. Now, if you look at it, the key words we have in here is that it's well-defined. Okay, it is a collection. It's not made up of a single object. It's a collection. And another key word is that they are of the same kind. The same kind. So when you take the example of the first one, our first example, which we have here, okay, so it's Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, and Saturday. If I should include this object, July, the moment I include July in this first example, this collection ceases to be a set. It's just a collection. It's no longer a set, because the objects are not of the same kind. Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, they are of the same kind. But July is not of the same kind with these 7. Monday, Sunday, Tuesday, Wednesday, Thursday, Friday, and Saturday. So the presence of July changes the character of this collection. So it ceases to be called a set. It's no longer a set because of this, the presence of July. Because July is a month, it is not a day of the week. All right. So a set is a well-defined. So it is not relative, like as in happy people in your class. So Kojo can say, all right. So Kojo can say, Ajwa, or let me use a different way, can say Ya, okay? Can say Ya is happy. Kojo can say Ya is happy, but Yao may disagree. Okay, so let me use a different color to bring the differences out. No. sorry. Okay, let's use this green. Okay, let's use the what? Okay, so Yao may not think so. Okay, so Yao may not think say Ya is happy. So for Yao thinks Ya is sad, but Kojo thinks Ya is happy. So happiness is relative. It depends on a person's opinion. Somebody may think you are happy, another person may think you are not happy. So we can't consider the example to happy people in your class because of the happiness attribute is not well defined. It's not very clear cut. So it makes it difficult to say that happy people in your class is a set, because a set should be able to fulfill this criteria of well defined. We've already explained the same kind, and it has to be a collection. It's not made up of a single object, it's a collection of objects. So that is it for the definition of a set. So when you think about a set, always remember these three things. A set should be well defined. A set is a collection of objects, and the objects must be of the same kind. These three things always characterizes a set. All right, let's go to the notation. Let's go to the notation. Sorry. So set notation. This is our second topic that we'll be addressing today. Set notation. Okay. Now, you see, in every language has certain words that are used to describe it. Okay, every language has its language, to put it in that fashion. So what I mean is that let's say you are studying English language. The study of English language, for you to know English language or understand English language, you need to know the words, the language English. So you need to know the verbs, you need to know the conjugation, you need to know the construction, the things that make English language. Okay, how it is expressed, the words by which English language is expressed. Okay, so let's take for instance, in English language, good morning. When you are greeting somebody and it's in the morning, you say good morning. But in French, you say bonjour. That's what I mean, bonjour. So the language is different. Okay, the language is different. So in set 2, when you are talking about set is a kind of language, and you need to know how to express the set language. And to be able to express the set language, you need something called set notation. Okay, set notation. So that's very important when you are studying set notation. This is our second way. Sets are conventionally denoted or represented by capital letters. For example, capital A, capital B, capital C, capital Q, capital Y. Okay, so we represent sets with capital letters. Y. So we don't use small letters to represent sets. This will be wrong. This is accepted. All right. Now, and how do we present the members of a set? We use something called curly brackets like this. Curly brackets. Okay, curly brackets. It looks like an S. Curly brackets to present the members of a set. So in presenting the members of a set, we'll have something like this. Y equals, let's say we have the set of what? Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and Sunday. Sorry, Saturday. That should be Saturday. We've already written the Sunday. Okay. So that's our set. So we didn't use a small letter. We didn't use small letter. We used a capital letter. And the members are presented in a curly bracket. You don't present the members in a square bracket or like this. If you do that, that is not a set. That will be some words or whatever numbers in brackets. But the moment you present them in curly brackets, everybody knows that you are talking about a set. Okay? Alright. Now, we need to understand this. The components or objects of a set are called members or elements of a set. Okay, so let's write that down. It's an important point. The components or objects of a set are called members of a set. Alright. So they are called members or elements. Let's bring that one in. Members or elements of a set. So that's something we should know. Members or elements of a set. Alright. Now let's do some example. But before that, we need to understand that so far we've been using, if you look at our example, we've been using days, numbers, but we are dealing with mathematics. Happy people, okay? But we'll be delving into the numbers soon. But I need you to understand that maths is not difficult. Maths is very simple. It's one of the easiest subjects you can have, because maths is structured. You can score 100% in maths, but you cannot score 100% in English language. If you write an essay, no teacher will give you 30 over 30 or 50 over 50. The best you can get is maybe 25 over 30. Okay, but in mathematics, you can actually score 30 over 30, because maths is about principles, it's about rules. So once you understand the rules and the principles, the rest is so easy. Okay, all right, so let's go on. Now, a member or element of a set can be anything. Okay, it can be numbers, it can be people, it can be letters of the alphabet, it can even be other sets. All right, so let's take, for example, let's look at this example quickly. Let's say we have a set A. So let's say we have a set A, and the set A is 2. The members are 2, 4, 6, and 8. Remember the curly brackets. Then, okay, so for example, you have this set 2, 4, 6, 8. Now, if you look at this set, what do you think they have in common? Okay, let's study this a bit. What do they have in common? What do they have in common? Look at 2. look at 4, look at 6, look at 8. What do they have in common? They are all even numbers. Even numbers. Okay, that is why they are in a set. If I should add 7 to this set, it ceases to be a set, because 7 is not an even number. Remember we said that for a set to be a collection of objects, to be a set, it must be well defined. Okay, it must be well defined. Okay, and it must have, let's refer it to a bit. Okay, it must be well defined. It must be of the same kind. But when you look at this, if I add 7, they are not of the same kind. But 2, 4, 6, 8, they are all even numbers. They are all the same kind, and it's a collection. It's not just one, and it is definite. All right. So just trying to refresh our memory on what a set is. Okay, so let's clean that up. Let's clean this up and go back. All right. Okay, so the other thing that a symbol that we want to introduce is this symbol. Okay, this symbol. Or let me write it well. It is a symbol. It goes like this and like this. Good. It simply means is a member of. That's the meaning of that symbol. So that's another set notation. So we've talked about the curly brackets. We've talked about representing set with a capital, with capitals, not small letters, capitals, like we have in here. Okay, like we have in here, capital. Okay, this. All right. So we are presenting another notation, which is this notation. It means it's a member of. Now let's take, for example, we have this. Okay, our set A, 2, 4, 6, 8. Now if you want to express, we want to say that 2 or 4 is a member of the set A. The question is, how do we write the set language? How do we write it? This is how we write it. If you want to say, if you want to say that 4 is a member of set A. If you want to say 4 is a member of set A, this is how we write it in the set language. Okay, so we write it like this: 4, all right, A. All right. So 4A. So that means that 4 belongs to A. Four belongs to A. Okay. So 4 is a member of set A. It's written like this. Okay. So we write it that way. 4 belongs to A, or 4 is a member of the set A. So if you want to write 2 is a member of set A, this is how we write it. Okay, so the moment you see this, you know that, oh, you are talking about set. 2 belongs to A, not A belongs to 2. So 2 is a member of the set A. Okay, so this symbol, remember it. This symbol means it's a member of. Okay, that's what it means. It's a member of. Okay, so we'll be bringing the class to a close very soon. But there is also another notation we need to take note. In as much as this means this, okay, in as much as this means it's a member of, if you write it like this and cross it, guess what it means? It means it is not a member of. Okay, so that's what it means. It means it's not a member of. Now, most of the times when you see a sign and it has been crossed, usually it's safe to conclude that it means not. It means the opposite of that sign when it is not crossed. So not, it's not a member of. So let's look at this example. Our set 2, 4, 6, 8. We can safely say 7. Remember, we included 7 in here, which is an odd number. So we can say that 7 does not belong to the set A. Also, 7 is not a member of the set A or does not belong to the set A. This means the same. So when you see this sign, it means it's not a member of or does not belong to that set A. Now, there's another notation I would like us to take note of. So far we've talked about presenting sets with capitals. We've talked about describing the members or elements of the set. Okay, presenting the members or elements of the set using a curly bracket. The third thing we've talked about is that the symbol is a member of. How do we describe whether a member of a set is actually a member of a set? So let's say 2, like we said, 4 belongs to A. 4 is a member of A. Okay, so we've talked about that. Now, the next thing we want to talk about, how do we write the number of members or elements of a set? Now, that's very simple. If you want to write the number of members, okay, the number of members of a set, the number of members of a set. Okay, if you want to write that, this is how I write it. So we are using the same example of A, curly bracket, 2, 4, 6, and 8. Alright, so we go down a bit. Let's go down to create some space for ourselves. Okay, so the number of members of a set, A equals the set of 2, 4, 6, 8. Now, if you want to write the number, how many members are in this set? If you count it 2, 4, 6, 8, that's 4 members. Now, if you want to write the number of members, that's how we write it. N. We use this N into bracket. A. Note, this is not a curly bracket. Okay, equals to 4. So the moment you see this, what you are trying to say is that the number of members in the set A is 4. You get it? N into bracket A equals to 4. The number of members of the set A equals 4. Alright, so you can also write it like this. Remember we said the cross, when you have a sign and it crosses like this, usually with the cross we say it's not of. It's not. So let's say we write N is not equal to 5. You get it? We are just trying to extrapolate what we've learned already. Okay, so if you cross a line, this means that N, the number of the members of the set A, is not equal to 5. That's what it means. Alright, so let's erase this. Sorry. Okay. Move up. Now, take note of this. The number of elements in a set is also called the cardinality of the set. Okay, so let's talk about the cardinality. Okay, so take note of this point. The number of elements in a set, okay, is called the cardinality of the set. That's all. Right, so just remember that keyword there, this term, cardinality. The number of elements in a set is called the cardinality of a set. So I can ask you this question: what is the cardinality of the set A? Okay, the cardinality of the set A. So the cardinality of the set A is what? 4. You get it? What is the cardinality of the set? Let's say I have another set A, B. Then I have the set 3, 5, and 7. Let me write the notation well. Sorry about that. Okay, so let me, it's too close to. Okay, so we have B, 3, 5, and 7. Okay, I've written it well. Wonderful. So, if I should ask you, what's the cardinality of the set B? The cardinality of the set B is basically the number of elements in the set B. And the number of elements in the set B is what? 1 is simply 1, 1, 2, and 3. That's all. So how do we write this? We write it like this: NB equals 3. That is all. Now, the last thing I would like to show you here is this. Okay. Now, when it comes to cardinality, okay, of the set A, okay, let's say cardinality. Cardinality is usually denoted using the symbols. It's a very simple symbol, nothing complicated. This, okay, these 2 lines. So you have the set in between the 2 lines. So when you see it like this, we see a set written like this. It means cardinality. So B like this, it means the cardinality of B. So this is just cardinality. Cardinality of B. Okay, and this is cardinality of A. Alright. Alright. So the cardinality of B, the cardinality of B is of B. The cardinality of B is equal to this: the number of elements in the set B. You get it? It's just a different way of saying. Remember, we spoke about a set being a language, how you express it. Okay, so it's just like saying, using a word like happy. Okay, happy. Happy also means delight. Okay, it means excited. It can also mean excited. So this is one way of expressing this. So cardinality is synonymous with what? The number of elements in B. It means the same thing. Okay, so this is cardinality of B, and this is the number of elements in set B. They are equal. So when you see these two lines and a set is in between it, don't be scared. It just means the cardinality of P. It means the number of elements in the set P. And take note of this. We also have sets which have infinite cardinality. When we say something is infinite, let me write it here. When we say something is infinite, it means it never ends. It goes on and on and on and on. Okay, it's infinite. It never ends. Now, when we have this set, the set n of natural numbers, okay? So what's the natural numbers? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you can read 1 to a million, billion, trillion, all the way. It never ends. It's infinite. Okay, so the cardinality, so we have infinite cardinality. All right, we have infinite cardinality. And an example of an infinite cardinality is the set n of natural numbers. Okay, set n of natural numbers. It has infinite cardinality. All right. So to recap quickly. We spoke about a set must be represented by capital letters, not small letters. Don't forget that. And when we are describing the members of the set, we use curly brackets and we put the members inside. Remember that? Okay. And the third thing we learned about the set notation. Remember the symbol? Okay. It's a member of. Okay. It's a member of. So we gave some examples and we said A. Okay, let me use this one to make it more relatable. So this set 2, 4. This set. Okay. So we can say, let's say A equals to this set. Okay. Let me use this example here. So let's say we have the set A 2, 4. So what we say is this: 2 is a member of what? A. Beautiful. Good. Then we spoke about the symbol, remember? With a cross. Yeah. And we say anytime we have a symbol with a cross, it usually means not of. Okay, so this means not a member of. Okay, or it's not a member of. So referring to this set again, we can say 5. We can say 5 is not a member of A. I hope that's clear, because you see the set of 2, 4. 5 is not part, so you say 5 is not a member of A. And we also spoke about cardinality. The 5th point, we talked about cardinality, and we said cardinality is just used to indicate the number of elements in a set. So we express it as NA. So let's say NA is 2. Okay? Using this example. Okay? So the members are 2. 2, 4, 1, 2. Alright, so let's move up a bit. Alright, then we also talked about cardinality. We spoke about cardinality, we discussed it. Okay, but cardinality is just the number of the members of an element, and it's written like this. Okay, like this, right? When you see these two lines on both sides of a set, it simply means the number of is the same as this. Okay, they are equal. Cardinality. We also said that some sets have infinite cardinalities. Okay, so that brings us to the end of the end of definition of a set and set notations. And I hope you enjoyed this lesson. Until we meet again, God bless you, and remember, Jesus loves you. Amen.